Good morning, students. We'll start with the today's lecture. In the previous lecture, we have seen how to obtain the state model of the given electrical system, right? And we have seen what is the concept of state variable, right? State diagram, state model. And state model consists of state equations and the output equations. That also we have seen. And yesterday we have solved one of the numerical state model of the given electrical system, and we'll proceed with a few more numericals to obtain the state model of the given electrical system, right? Okay. We'll consider this electrical network. Obtain the state model of the given electrical network, right? Okay, this is the given electrical network. This is the input E1, and it has inductor L1 and L2 and capacitor, and the load is R1, and the output is E2, right? Okay. And one more important thing before solving these kind of problems means if it is asked for you people to obtain the state model of the given electrical network, right? So you should be very careful. Based on the sequence of selection of the sequence of state variables, the state model changes. It is not unique. See here, they got A matrix, this one B, C. The elements will be same, but not will be in the same order. Because I will be here, the current passing through this inductor I1, I will be taking it as x1 or x2, it depends, right? So this I will take it as x1, this as x2, this as x3. Some people will take this as x1, x2, x3, right? Based on the selection of the state variables, right? These vectors are going to change, but the elements will be same, but they will be in the not in the same order, right? So you should be very careful. Don't try to match your answers, but if all the elements are there, then it is fine, right? Don't try to match. If you have taken the same variables as in the textbook or whatever the solution, then you will get the same matrices. Please keep in the mind, right? Okay. Okay, which are the energy storage elements here? Inductor and capacitor. Let me take this as state variable as x1, right? And this another inductor as x2, right? And the voltage across capacitor, this is the energy storage. Let me take it as x3. So they have also taken here. So x1 is I1, x2 is I2, x3 is VC, right? If I take in the same order what they have taken, I will get the same answers. But in the answer there is a mistake here. Instead of 1, I should get 0. Let me do it later, right? Okay. Okay, I have chosen this as x1, this as x2, the current flowing through this inductor L1 as x1, the current flowing through this inductor L2 as x2, then the current, the voltage across capacitor as x3, right? So select state variables. Let me write it. Select state variables. So I have selected already. So x1 is equal to what? L1. Sorry, current. We have to take the variable. Current flowing through this inductor is I1. Then x2, the current flowing through this inductor L2 is I2. Then the voltage across capacitor, let me take it as x3. Okay, which is the input? We will select which is the input? U. See here, u of t I will not write it because all our functions are of time only. X1 of t, x2 of t I will not write. Simply I will write x1, x2, x3, u, right? U means u of t. All are functions of time only. So here input is E1 and output, that is y. So it is E2. Okay, we'll write the state equations, right? Sorry, state model equations. First state equations I'll write. State equation, general state equation, right? What is the general state equation? X dot is equal to ax plus bu. So I am not writing x dot of t, a into x of t. They are all functions of time only, right? So ax plus bu. Then output equation. So y is equal to cx plus du. So these two equations forms the state model. Whenever it is asked to obtain the state model means you have to get the state equation as well as output equation both, right? Okay, this is the state model. Then what are the size or order of these matrices A, B, C, D? Just I'll write it here. A, B, these are the coefficients or matrices of state equation. Then C, D, they are associated with the output equation, right? So let me write the order here. So n cross something. So here these are output equations. So P represents output, right? P cross something. So what is M? N, P will write M. The number of inputs. How many inputs are there? Only one input. So M is 1. Then N, the number of states. How many? 1, 2, 3. 3 state variables are there. So the number of state variables Mn. Then P, how many outputs are there? Only one output, right? Okay. So Nm, how to write? I already told Nm. So if you write this much, you will never go wrong, right? So what is n cross m? 3 cross 3 matrix you will get. Then n is 3, m is 1, 3 cross 1. So matrix A is of the order 1 cross 3. Then P 1 cross m is 1. So this is the order of these matrices, right? Okay, we'll proceed. So let me call this as loop 1, then loop 2. Then we apply KVL for yesterday. I have not applied, right? This is not that problem. I will take up that problem next, right? Okay, this is loop 1, loop 2. We will apply KVL for both the loops, right? So applying KVL, apply Kirchhoff's voltage law for loop 1. So what is the equation I'm going to get? E1 is equal to L1 into di1 by dt. L1 into di1 by dt. Next, this is voltage plus Vc, right? Plus Vc. Call this as equation 1. Next, apply the KVL to this loop 2. So Vc is equal to voltage across capacitor Vc is equal to L2 into di2 by dt plus directly I can write this output, or else I can write I2 into R1. I2 into R1. Is it fine? I2 into R1. Yes, fine. Okay, let me have a look at it. What's the current that is flowing through this capacitor here? It is I1 minus I2, right? So if I add I1 minus I2 and this one, I am getting back I1. It is correct, right? So I1 minus I2. I2 will get cancelled. I am getting I1. It is correct. Okay, if it is used later, we will see it. Okay, fine. Then what all the things I require? X1 dot, because X1 dot, X2 dot, X3 dot I require. First, let me find out X1 dot. X1 dot is nothing but X state. First, let me obtain the state equation. So X1 dot. What is X1 dot? di1 by dt. di1 by dt. So I wanted this, right? You can observe equation 1, di1 by dt is there. So let me get di1 by dt from equation 1. So equation 1 implies, so di1 by dt is equal to, so into L1 is there. So 1 by L1, open bracket. So E1, so minus Vc. If I take it this side, minus Vc, is it fine? So L1 I have taken. So I can write it as 1 by L1 into E1 minus 1 by L1 into Vc. So let me write it di once again, di1 by dt. Okay, let me replace it, I think, right? So what is di1 by dt? It is nothing but x1 dot, right? So we'll replace it, x1 dot. So 1 by L1 as it is. What is E1? E1 is your U. E1 is U. So E1, I'll write U minus 1 by L1. What is Vc? Vc is x3. So x3. So let me rearrange it and write it x1 dot, because first I should get states, then I should get input. So let me rearrange 1 minus 1 by L1 into x3. So I am getting the state variables first, then next the input plus 1 by L1 U. So call this as equation 3. And this is required for constructing the matrix. Let me put it in the box so that it will be easy for me. Okay. Next, x1 dot is over. Next, we will obtain x2 dot. So what is x2 dot? It is di2 by dt. I2 dot is nothing but di2 by dt. Okay, from equation 2 you can get di2 by dt. Is it fine? So equation 2 implies, so di2 by dt is equal to 1 by L2. L2 is there, I am taking that side. So Vc minus I2R1. I2R1. So let me write it 1 by L2 into Vc minus 1 by R1. 1 by means R1 by L2. R1 by L2 into I2. Okay. Then next we will replace it. What is di2 by dt? It is nothing but x2 dot. Then 1 by L2. What is this VC? VC is nothing but x3 minus R1 by L2. Then what is this I2? I2 is nothing but your x2. Right? So call this as equation 4 and put it in the box so that it will help me to write the matrix. Okay. Next we will try to obtain x3 dot. Right? So x3 dot. So x3 is VC. X3 dot means dVC by dt. Right? So dVC by dt. So we have obtained all these things. What is VC here? So we made use of already KVL equation, right? So what is VC? So this is the voltage across the capacitor, right? So VC is equal to 1 by C into integration of I1 minus I2 into D, right? So that is VC. So first let me write what is VC. 1 by C into integration of I1 minus I2 into dt. Is it fine? So the voltage across capacitor VC is equal to 1 by C into integration of I1 minus I2 into dt. Is it fine? Okay. Then next I want dVC by dt. So I have to take differentiation. So let me proceed here. dVC by dt is equal to, so 1 by C, this integration will vanish, right? So I'll be getting I1 minus I2. So dVC by dt is equal to 1 by C into I1 minus 1 by C into I2. Right? We'll replace. What is dVC by dt is nothing but x3 dot. So 1 by C, whether it is 1 by C or 1 by C1, 1 by C only. Okay. We should be careful with notations. It is L1, L2. Here it is simply C. It is not C1, right? So 1 by C. What is I1? I1 is x1. So x1 minus 1 by C. What is I2? I2 is x2. So call this as equation 5. 3, 4, 5. Next. So put it in the box. Okay, now I can write the state equations because I have all the three equations, x1 dot, x2 dot, x3 dot. So let me write state equations, then proceed with the output equation, right? So state equation is x dot equal to ax plus bu. So I'll call for x dot equal to ax plus bu. So what is x dot? Three state variables are there. So I'll be getting the column vector x1 dot, x2 dot, x3 dot. Then vector A. Vector A, what is the size of vector A? 3 cross 3 matrix, right? Let me 3 cross 3 matrix. So one element, second element, third element, 3 cross 3. Let me put the dots so that I can fill it. So I'll be getting 3 cross 3. Then what is X? It is 3 states are there, X1, X2, X3. So B is, what is the order of the matrix? B, it is 3 cross 1. 3 cross means 3 cross 1 means 3 rows, 1 column. So first element, second element, third element, 3 cross 1, right? Then into U. How many inputs are there? Only one input. So U. Is it fine? Next, we will have to fill up these elements looking at the equations 4, 3, 4, 5. Yes, come to this x1 dot. Is there any x1 here? No, x1 is not there. X1 is not there, so it is 0. So let me fill it here. So x1 is 0. Is it fine? Then come to this next equation. So is there any x1 here? No x1. So once again 0. Come to this last equation x1. Yes, the coefficient of x1 is there. It is 1 by c. Write it. So in the first column, you fill up the coefficients of x1 of third equation, fourth equation, and fifth equation, 3, 4, 5, right? Then next x2 column. So come in the order only. So are there any coefficients of x2 here? No, 0. Then come to next equation, equation 4. So are there any coefficients of x2? Yes, minus r1 by l2. Minus r1 by L2. Are there, next observe the fifth equation, are there any coefficients of x2? Yes, minus 1 by c. Next in the column 3, x3 coefficients I have to write x3. So x3 coefficients, go to first equation. Are there any x3? Yes, it is there, minus 1 by L1. Come to the second equation. Are there any coefficients of x3? Yes, 1 by L2. Next, are there any coefficients of x3 in the equation 5? No, it is 0. I hope you are getting how I written, right? If any doubts, you can unmute yourself and talk to me so that I can tell you once again, right? Then come to this A. This is A vector. This is A vector. Ax plus Bu. Next B vector we have to fill up, right? So observe, go to the equation, first equation. Yes, coefficient of U is 1 by L1. So 1 by L1. Next, come to next equation. Are there any coefficients of U itself is not there, so it is 0. Last equation, equation 5, U itself is not there, so it is 0. So this is vector A, this is vector B. You can cross verify with the answer here. 0, 0, 1 by C, you can observe here. 0, 0, 1 by C, 0 minus R1 by L2, minus 1 by C, you can verify, right? So minus 1, 1 by L1, 1 plus 1 by L2, 0. So this is correct, vector B. In vector B, this is 0. Actually, in the textbook, they have given wrong. This is correct. This should be 0, right? So we are getting 1 by L1, 0, 0. 1 by L1, 0, 0, right? So state equation is obtained. Next, output equation, because they have asked state model. State model, we have obtained state equation. Next, we will get the output equation, right? So we will get the output equation. So what about y? Output. So output, what is the output here? Y equal to E2. So what is this E2? That's right, E2 is equal to I2 into R1. E2 equal to I2 into R1. E2 equal to I2 into R1. This is the output, right? Okay. What is E2? We have taken E2 as Y, right? Y. So R1 as it is. What is I2? I2 is X2. So X2, right? So what is the output equation? General output equation. Y is equal to Cx plus du, right? So Y, only one output is there. It is not a vector, just Y. Then what is the C? C, what is the order of this matrix C? So it is 1 cross 3. 1 cross 3. One row, 3 elements are there. 1, 2, 3. Right? 1 cross 3. One row, 3 columns. Then X. How many states are there? X1, X2, X3. 3 states are there corresponding to this X. Plus D vector. What is the matrix size of D vector? 1 cross 1. Only one element is there. One row, one column. So one row, one column. Then this is U. Right? Okay, we have to fill up this. Okay, observe the output here. So you observe this equation, output equation, whatever we got, call this as equation 6. Observe this equation 6. Observe here, is there any x1 is there? No. X2, the coefficient of x2 is r1. Is there any x3 here? No, it is 0, right? 0, r1, 0. X corresponding to x1, corresponding to x2, corresponding to x3. Then come to D here. Is there any u? Only state variable x2 is there. Is there any u? Nothing is there. So it is 0. So this is matrix B and this is matrix D. So thus the state model is obtained, right? Are there any doubts? You can ask. So 0, R1, 0 and this is only 0. You can check it here. 0, R1, 0 and this is D is 0, right? Okay. So state model of the given network is obtained. What is state model of the given network? Getting the state equation, this one, right? This state equation, this one, and the output equation, this one, we obtained, right? So this consists this we call it a state model, right? Thus state model is obtained. Thus state model of the given electrical network is obtained. Okay. Next, we'll move to the next numerical. If any doubts, this problem is over. I will take up the next numerical. Yesterday I have done it wrong, so now I corrected myself, right? Okay, this one yesterday we have taken, right? For the given electrical system shown in the figure 14.4.5 actually, right? Okay, 5. Determine the state variable model, or simply instead of saying state variable model, simply they can say or state model, simply state model. Obtain the state model. of the given electrical network, right? Okay. Input is Vi. So the resistor R is 1 ohms. Here the resistor R is 1 ohms. The inductor L is 1 Henry. The capacitor is 1 farads, and this is the output voltage V naught of T. So one more thing, this please note these points. For every problem of the state model, based on the selection of sequence of state variables, the state model changes. It is not unique. So how many energy storage elements are there in this network? So one is inductor and another one is capacitor, means two state variables are there. So I can take the current passing through this inductor as x1 and the voltage across this capacitor as x2. Or another way, I can take this voltage across capacitor as x1 and the current passing as x2. So then the state equations will change. The state model will change, right? I hope you're getting, right? So the answers vary based on the selection of the state variables. Don't worry, right? So I have this first energy storage element inductor. The current passing through it, let me take it as x1 and the voltage across this capacitor as x2. Okay, let me take the currents here. So I'll call this as I1, the current passing through this, then this as I2, and here it is I1 minus I2. So if I add this both, if I so the current divides here through the branches. If I add both, I am getting I1, right? I2 it will get cancelled. I am getting I1, right? So the convention of current is right. So this is loop 1 and this is loop 2. Is it fine? Okay, we'll proceed. I'm taking this as x1. X1 is I2. X2 is Vc, the voltage across capacitor. Let me write it as Vc, voltage across this capacitor, right? Right? Voltage across this capacitor, Vc. This is x2. So let me select state variables. Select state variables. So what is x1? So x1 is the current flowing through this inductor L equal to 1 Henry. That is I2. I2. Then x2, second state variable is the voltage across this capacitor Vc. Is it fine? Vc. Then which is the input? Input U. Input is U. What is input here? Vi. Vi of t means simply I will write Vi. I will not write Vi of t. They are all functions of time only. Then output Y. What is the output Y here? V naught of t means simply V naught I will write. Right? We have identified. Then next, let me write the state model equation, state equation. State equation. So x dot is equal to ax plus bu. Then output equation we will write. So y is equal to cx plus bu. So these two equations will form the state model, right? We have to get both. So next, what are the matrices orders we have to write? A, B, C, D. So here these two for state equation. So n cross something, n cross something. These are output equations. So P is output, right? So P cross something, P cross something. So n, m, n, m. You write it so that you will never go wrong, right? So what is m and p? We have to identify. How many number of inputs are there? Only one, right? So only one input. N, the number of states. 1 to 2 states are there. Two state variables, right? X1 and X2. Then P, the number of outputs. Only one, V naught, right? So 1. So you'll write n cross n means 2 cross 2 vector. A is 2 cross 2 vector. B is n cross m, 2 cross 1. So P cross n means 1 cross 2. P cross m means 1 cross 1. So if I write this much, so I will get an idea, right? So let me apply KVL. Apply KVL for loop 1. So loop 1, this is loop 1 and this is loop 2. Let me apply KVL for loop 1. Vi is equal to I1 into R, I1 into R plus, here, observe here, I1 minus I2 into R, I1 minus I2 into R, I1 minus I2 into R. Is it fine? I hope you understood, right? I1 into R. So this one is the current flowing through this resistor is I1 minus I2 into R. Is it fine? So this is 1 minute. Okay, fine. Call this as equation 1. But what is the value of R here? It is 1 ohms here it is also 1 ohms here. Let me substitute and write it. Vi is equal to I1. R is 1 ohm, so I will leave it. So I1 minus I2. That's all, right? So I1 will get cancelled, right? Vi is equal to I2. That directly I will get. But oh, okay. I think that is fine. I think Vi is equal to I2. That is fine. Okay, fine. So I1 will get cancelled. So Vi is equal to what? I2. I got it. Is it fine? But this will.
Sir, it's 2I1, sir.
Yes, I cannot cancel. No, okay, thank you. Thank you very much. Okay. 2 times I1. Right. Fine. Thank you. I1 plus I1. I cannot cancel. Let me write it here. I1 plus I1 minus I2. So 2 times I1. Yes, fine. Thank you. So this type of mistakes I will be making. Please correct me. 2 times I1 minus I2. I hope now it is correct, right? So call this as equation 1. I hope this is correct, right? Yes. 2 times I1 minus I2. Fine. Okay, next up we will apply the KVL for the second loop. Second loop, this one, right? So this one, the voltage across this I1 minus I2 into R, I1 minus I2 into R is equal to, I will be taking like this I will treat it as source. I1 minus I2 into R is equal to L into di2 by dt. L into di2 by dt. Next, the voltage across this capacitor, I can take it as Vc directly, right? Or else I have to write that. And let me take it as Vc. Voltage across this capacitor is Vc, right? Plus Vc. So call this as equation 2. No, sorry. Let me substitute. What is R here? I1 minus I2. R is 1 ohms. So I will not write. So what is L? It is 1 Henry. So di2 by dt plus Vc. Call this as equation 2. Is it fine? Okay. So we have equation 1 and 2. First, how many state variables are there? X1 and X2. So I want X1 dot. X1 dot I want. So I want X1 dot. So what is X1 dot? It is I2 dot. I2 dot is nothing but di2 by dt. di2 by dt I want. So observe this equation. So from equation 2 I will get di2 by dt, right? So from equation 2 implies di2 by dt is equal to, so di2 by dt is equal to I1 minus I2 minus Vc. I1 minus I2 minus Vc. So I1 minus I2 minus Vc. Is it fine? Correct? Okay, fine. But you can observe here I1, it is, so we don't have any energy storage elements in the first loop. So I will, what is the equation for I1? From equation 1 I will get what is the equation for I1. Let me write it here only, which implies I1 is equal to what? 2 times I1 is equal to, let me write it here only, 2 times I1 is equal to Vi plus I2. Is it fine? Vi plus I2, but I1 is equal to, let me write it here only, I1 is equal to Vi plus I2 divided by 2. So I can write it as, I can split it and write Vi by 2 plus I2 by 2. So we'll make use of this equation, substitute, call this as equation, I have called anything, right? Call this as equation 3. Substitute this equation 3 here, substitute using equation 3, use equation 3 here, using equation 3. So let me write it, di2 by dt. So what is I1? We have I1 is Vi by 2, Vi by 2 plus I2 by 2. I have substituted for this I1, right? So Vi by 2 plus I2 by 2. Next, minus I2 minus Vc. So let me rewrite it, di2 by dt is equal to 1 by 2 times Vi. So this is half, 1 by 2 minus 1. So minus half I will be getting, minus 1 by 2 I2. Is it fine? So half times I2 minus 1 times I2, right? So minus 1 by 2. This is minus Vc. Okay. What is di2 by dt? It is x1 dot. So let me replace it, x1 dot. Half times, what is Vi? What is Vi? What I have chosen? Vi is u, right? Vi is u. minus half times what is I2? I2 is x1. I2 is x1 minus what is VC? VC is x2. Alright. So let me rewrite this. X1 dot is equal to, let me write this state variables first, minus half times x1 minus x2, then I will write the input plus half times u. So call this as equation 4. So and I'll put it in the box because this will help me to write the matrix later on, state equation. Next, what I want? X2 dot. X2 dot I want, right? So what is x2 dot? X2 is VC. X2 dot is dVC by dt. So dVC by dt. Then what is VC? First we will write what is VC. What is voltage across this capacitor? So it is the current flowing 1 by C into integration of I2 into dt, right? 1 by C into integration of the current flowing through this capacitor I2 into dt. So 1 by C into integration of I2 into dt. Yes, is it correct? Then next, I want dVC by dt. Take differentiation of VC with respect to time. dVC by dt. So 1 by C into I2, that's all. This integration will get cancelled. So I am getting this. So we will replace what is dVC by dt. So let me write it here only. What is dVC by dt? It is x2 dot. x2 dot. 1 by C as it is. What is I2? I2 is x1. x1. So put it in the box. Call this as equation 5. Right, now I can write the state equations easily. Right, let me write the state equations. So state equation, x dot is equal to ax plus bu. So how many states are there? Two states, right? So x1 dot, x2 dot. This is the column matrix. So what is vector A? What is the order of vector A? It is 2 cross 2. So 2 cross 2. So let me put the dots here. Two states are there, x1, x2. So A is over, X is over. Next B. What is the order of B? B is 2 cross 1. 2 cross 2 rows, right? 2 cross 1. Right? 2 cross 1. 2 rows, 1 column. Then U. U is only 1. Right? U. So let me make use of this equation 4 and 5 and write it. So this is x1 dot, x2 dot, right? So just we'll fill up the coefficients of x1 first. So observe this equation. Coefficient of x1 is minus half. So let me write it here. So from next equation, coefficient of x1 is 1 by C. 1 by C. So value of C I have not substituted. Actually 1 by C. Let me substitute and write. Let me rewrite it. Right? X2 dot. I am rewriting. Why capacitance? It is 1 farad. 1 by 1 is 1 only. So let me x2 is equal to x1 only. So let me put it in the box and call this as equation 5. Is it fine? I have substituted. So what is the coefficient of x1? It is 1. So let me write as 1 here. Right? Simply 1. I hope you are getting. C is 1 farad, right? So 1 by 1 is 1 only. Next, here x2 I have to write. So coefficients of x2 in first equation, coefficients of x2 is there? Yes, it is minus 1. So let me write it here, minus 1. Then what is the coefficient of x2 in next equation? Is there any coefficient of x2? No, it is not there, means 0. Next, come to the u part, that is input. Is there any u? Yes, the coefficient of u is half in the first equation. So write it half, 1 by 2. Then in the second equation, is there any u input? No, it is not there, means 0. So this is vector A and this is vector B. So I have taken the same state variable, so I will be getting the same answer. So minus half, minus 1, 1, 0. Minus half, minus 1, 1, 0. B is 1 by 2, 0. Right? Yes, I got it. Next we'll go to the output equation. Output equation. Yes, what is the output here? Y I want, right? So what is Y here? Y is nothing but here V naught, right? So V naught. What is V naught? V naught is nothing but your C, voltage across this capacitor. VC, right? V not equal to VC, can I write directly? What is this VC? It is equal to X2. I hope you are getting V not equal to VC. So VC, what is this VC? What is this VC? It is equal to X2. So let me write it. So it is X2. So Y equal to X2. So put it in the box and call this as equation 4 means next 6. 5 is over, next 6. So this is the output equation. So from this we'll construct the matrix Y is equal to Cx plus Du. So Y, only one output is there. So what is the order of this matrix C? C is 1 cross 2. 1 row, 2 columns. What is X? Two states are there. X1, X2. Plus, what is the size of D? It is 1 cross 1. Only one element will be there. Then U. Is it fine? Right? So, observe this equation. What is the coefficient of x1 here? Nothing, 0. What is the coefficient of x2? It is 1. Next, is there any U input? Nothing. So, it is 0. So, this is this C matrix and this is D matrix. You can 0, 1 and 0. You can check it. 0, 1 and 0. C is 0, 1, D is 0. I hope you are getting. So, this is the state model. So, this completes state model problems. And next, I will ask you people, I will give some time, just I will pause the recording or I will stop recording, right? I'll stop recording.